Hi everyone, in this video we are going to talk about methane. So why are we talking about methane? Well, we're in the context of global warming and climate change. And so methane is one of those species that exists naturally in our environment that actually absorbs a lot of infrared radiation and reflects it right back down to the planet. And so it heats our planet to really bad. But basically it has a global warming potential of 21. And so if you remember, carbon dioxide only has a global warming potential of 1. So methane is a big contributor to our global warming, or the increase of the temperature of our planet, but it only has a lifetime of 12 years. So it's definitely worse than carbon dioxide, but it doesn't last as long, and so it's not necessarily interpreted as the worst thing for our planet, yet scientists are kicking and screaming about that because we know methane is really going to be a big problem in the next 5 to 10 years. Really bad. But let's not focus on that right now. Let's just talk about methane. Methane is one of our simplest hydrocarbons. So there's 1 carbon and 4 hydrogens. Very simple, very straightforward. But there's many different reasons why methane is in our planet right now, or in our atmosphere. And so there's some natural ones and there's some not so natural ones. So let's focus on the natural one first. And these actually happen a lot. And so they actually account for about 40% of the methane that actually exists in our environment. There's 3 of them specifically that I need you to know though, okay? So the first one is our wetlands. And so it's not just that we have wetlands, that doesn't just introduce methane into our environment, but what exists in wetlands are actually things called anaerobic bacteria. So let's spell this to make sure we get it correct. So it's A-N-A-E-R-O-B-I-C and then bacteria. So anaerobic bacteria is something that's very special, but what that word specifically means is without oxygen. So it's bacteria that is able to break things down when it's not in the presence of oxygen. So traditionally what happens is you have some source of fuel, whatever we want to call that. You treat it with oxygen and you create CO2 and water. This is a standard combustion reaction. But if you are in an environment that does not have oxygen, you physically cannot create carbon dioxide. You can't. There's no oxygen there. You can't create it. So this is not an option. So what ends up happening in these wetlands is this anaerobic bacteria takes organic material. So anytime I'm saying organic material, think carbon, think hydrogen, just a very standard. And what it does is it breaks it apart into CH4, so into methane. Can't create CO2, so instead it creates CH4. So this is constantly happening. This anaerobic bacteria is always taking this organic material and breaking it down to methane. This is the biggest source of methane that naturally occurs here on Earth. The second thing, though, are oceans. And so in oceans, we have these things that are called methane hydrates. Methane hydrates. Now, these are really cool for a pyro. Okay, I like to blow stuff up, so this is why I really like them. So here's what you have to envision. Methane is a little gas, okay, tiny little gas bubble, and what happens is it ends up getting trapped in these big cages. So you're in the ocean, right? What are these cages made of? Water. That's the only thing it could be. So you've got an oxygen here, hydrogen, then you're doing some hydrogen bonding over here to another oxygen, hydrogen. If you don't understand that, do not worry. We'll get to hydrogen bonding in a couple modules. But just know that you have these big water molecules that are trapping, they're working together and basically creating this big block, and they're trapping a little piece of methane. And so you have these methane hydrates that are floating around the ocean, and in certain little areas of the world, they kind of surface a little bit. You can hit it with a spike, give it a little source of fuel, and then excuse me, that's how excited I am. Whoosh! You have this huge fire. It shoots straight up to the top. It is one of the coolest things in the world. If you have a second, definitely go to YouTube and watch those videos. Very cool, but we don't have time for that right now. All right, so the last thing I want to talk about is termites. Oh, termites. Termites are one of the biggest contributors of methane naturally. And so what they do is they have these special enzymes that are in their stomach, and they can actually take cellulose and they break it apart into methane and water, okay? And actually carbon dioxide too, but whatever, that doesn't really matter. But what they do is they take the cellulose, they break it down, and they are able to create that methane. And so not only are these termites eating your house and breaking everything apart, they're also just releasing methane into the atmosphere. So termites are just no good. They don't, in my personal opinion, they don't contribute to society at all. Let's get rid of them. All right, so I'm going to leave you with one quick question. Here's what I want to know. What is the largest natural source of methane production? Go. All right, did you get an answer? Hopefully you did, because I literally just said it about 2 minutes ago in the video. But our largest natural source of methane production is definitely our wetlands, but more specifically, it's that anaerobic bacteria. Okay, so you're going to see this come up over and over and over again. But this anaerobic bacteria is really the biggest contributor, because what it does is, regardless of where it's like breaking something down, whether it's in a wetlands or anything else that we're about to talk about, this anaerobic bacteria actually comes in and constantly breaks things down and releases methane. But the problem is that humans are making it worse. We are giving it places. We're basically creating environments just like the wetlands to allow for this bacteria to do so. So let's go through a couple different of our human causes. I'm just going to call them human, but anthropogenic would be fine too. And please note that we are responsible for 60% of the methane in our environment. But let's break down how that actually works. One of our biggest pieces is rice cultivation. All right, now I absolutely love rice. I love eating rice. I totally enjoy it. But it's another environment that's exactly like the wetlands. You have everything that's in the water. It's below the surface. So there's not a lot of oxygen. So what happens is, again, this anaerobic bacteria, which I'm just going to refer to as A.B, this anaerobic bacteria comes in and it breaks this all apart, releases our methane into the environment. All right, what else do we have? Well, farming or agriculture, specifically cattle and sheep. Now, the word that I try to use in my adult life would be flatulence, but because we're talking to a bunch of different high school kids here, farts, okay? Farts. These cattle and sheep are constantly releasing gas. They're passing gas, which is purely methane. So what happens, these cattle and sheep eat, things go in their stomach, the enzymes break down the food in their stomach, and they release methane into the atmosphere. So just to kind of quantify this for you, specifically with cattle, they release 500 liters of methane a day per one cow. So one cow releases 500 liters of methane into the environment every single day, and that's just by passing gas, okay? It's not good. That is something we need to get on top of. Some people do what are called meatless Mondays to try to limit what's happening. I don't know, but just be aware of it, okay? These cattle are constantly passing gas. Same thing with sheep, and they're releasing methane into our environment. It's not good. We should try, as a whole environment, try to cut down on the amount of red meat that we're eating, because that's causing that. Moving on, though. We'll talk about that later. One of the other things that is human fault are landfills. So when you have landfills, you have to think about it. It's just a bunch of trash, right? So you have trash here, trash here, trash here, and it just gets bigger and bigger and bigger, but there's a lot of weight, and so it starts sinking down, and so it's compacted really, really close, and it's actually really difficult to get that oxygen gas back in there. So instead of breaking things down and releasing carbon dioxide in the atmosphere, same thing, that anaerobic bacteria, we're going to label it AB, comes in, breaks down that trash, releases methane in the atmosphere. The one silver lining positive thing is that some people are actually doing a bunch of research on how you can capture that methane gas that's being released from landfill specifically, and they're actually able to convert it to biogas, which is a source of fuel. So keep that in the back of your mind so that in the next unit, when we move into that, this sounds very familiar. All right, the last thing I want to point out is that we as humans use methane or natural gas all the time. We use it in our houses, we use it at work, we use it all over the place. And in order to get the natural gas, we use this process called hydraulic fracturing, or commonly known as fracking. Again, we'll talk about that later. But it's a process that basically digs deep down into these holes, these fossil fuel holes that have these little pockets of methane gas. You smash it, you release the methane gas. Well, you're not going to be able to capture it, all right? The gas is so tiny. You're at least one, if not two, or hundreds and hundreds and hundreds of molecules are able to slip out and get out of the way, so you're not capturing all of it. So even while we're trying to just extract it from our environment, we're releasing methane into the atmosphere. There was a huge methane leak that happened a couple months ago out in California. It was the worst incident of methane gas release in the history of man, they think. We'll see, we'll see when we get a little bit more data. But it's really, really bad. All right, remember, methane has a global warming potential of 21. Yes, it only has a lifetime of 12 years, but it's something that, or a molecule that absorbs that infrared radiation, reflects it right back down to the atmosphere, so it's really, really, really bad for our planet. All right, so instead of leaving you on that sad note, let's change gears just a little bit. I have one quick question for you. Humans release 60% of methane into the atmosphere. Methane has a global warming potential of 21. Should we consider decreasing our methane emissions? That's my question. Should we consider decreasing our methane emissions? Go. Did you get an answer? Hopefully, because I just got on a soapbox and talked about it maybe 4 seconds before I asked you the question. Should we consider decreasing our methane emissions? Absolutely. Do the best that you can to try to decrease it. I don't know if you live around termites, but get rid of some there. Try to get your cows to stop passing gas. Do whatever you can to try to reduce your methane emissions. Have a great week. Take care of yourself and drink water.